Okay, so let's go ahead and walk through question 4, which is related to passage 1 of the physics question pack. So the question here is asking about a frequency of light. On the MCAT, as soon as you see a physics question about either frequency, velocity, or wavelength, the first equation I want you to have immediately come to mind is that for the velocity of light, because this may be the single most tested equation on the MCAT. So you need to have it come to mind just like that. So this equation is going to be the velocity, or the speed of light, is equal to the frequency of light times the wavelength. And remember, wavelength is represented by the character lambda here. So if we go ahead and look at that equation, we can solve it for frequency. So we just get frequency is equal to velocity divided by wavelength. And then all we need to do is find those values in our passage. So we're told in the passage that the velocity of light is 3 times 10 to the 8th meters per second. But that's also something that you should just have memorized and not even need to check the passage for. Remember before I've said that it's super important that you make a deck of Anki cards for all the equations you come across on the official AAMC resources that you don't know? Well, on my card for my velocity of light equation, I would include this constant, the fact that the velocity of light in a vacuum is 3 times 10 to the 8th meters per second. So anytime you get an equation that has one of those constants, just go ahead and write it down on your card, and so you memorize that information. So this is the velocity of light in a vacuum. Remember that the speed of light depends on what medium or what substance the rays of light are traveling through. So when light travels through a denser substance, like for example, air or glass, then it slows down a little bit or sort of bends. And that comes to play in things like Snell's law that we'll cover in later problems in the physics question pack. But a vacuum provides quote unquote perfect conditions for light to travel through. That means there's no particles to sort of scatter it around or bend it. And because of that, light can travel at its maximum speed, which is 3 times 10 to the 8th meters per second. Unless you're told you're dealing with light passing through a specific medium like water or glass, then you should assume that you can use the velocity of light in a vacuum. So here we've got frequency is equal to 3 times 10 to the 8th meters per second. Always include your units here. Divided by our wavelength, which we're told in the passage is 6 times 10 to the negative 7th meters. And remember, wavelength is always, it's a length of something, right? It's always going to be measured in our SI unit for length, which is meters. Okay, so if we go ahead and do that division, we take 3 divided by 6, and we get a half, or 0.5. We always subtract our exponents in scientific notations. We get 10 to the 8 minus negative 7, which is going to be the same thing as 8 plus 7, or 15. So 10 to the 15th power. And then, of course, our meters are going to cancel out, and so we get 10 to the 15th, 1 over seconds. Remember, that's the definition of hertz, is 1 divided by seconds, or seconds inverse. So we could just go ahead and replace this. This is the same thing as hertz. Hertz measures frequency, or cycles per second. So 1 hertz means that 1 cycle of an event happens in 1 second. So that's why our units for hertz are just going to be 1 divided by seconds. So whereas our SI unit for length is the meter, our SI unit for frequency is hertz. So just like you have a deck for all the equations you don't know, you should also have a deck of Anki cards for all of your SI units. So you should have on one side of the card, what the quantity is, like length, and then on the other side of the card, what the SI unit is, like meters. Now, remember, this is not a proper scientific notation answer because 0.5 is less than 1. And we know for scientific notation, the number that we multiply our power of 10 by needs to be between 1 and less than 10. So we're going to have to move this decimal point 1 place to the right. And remember our helpful mnemonic LARS, which is if we move it to the left, we add. If we move it to the right, we subtract. So here we're moving our decimal place 1 place to the right. So we're going to subtract from our power of 10. So we're going to get 5 times 10 to the 14th hertz. And if we look at our answer choices, that's answer choice D. Now let's recap our important takeaways from this question that will help you ace future related MCAT questions. So number 1 is going to be the equation for the speed of light. Remember we said that that is velocity equals frequency times wavelength, which is lambda. And you should know that this is a super commonly tested equation, so you're going to need to use it on the MCAT. So be super, super familiar with it, be able to manipulate it, solve it for frequency, solve it for wavelength, etc. Our second takeaway here is going to be that the velocity or the speed of light has a constant value when we're traveling through a vacuum. And you should memorize that that constant value is 3 times 10 to the 8th meters per second. And then our last takeaway is going to be units. We said that our units for wavelength are going to be meters. So wavelength is going to be measured in meters. Our units for frequency is going to be hertz. which is the same as 1 over seconds, but our SI unit is going to be the hertz there. And our unit for velocity, of course, is meters per second. So I hope this helped. Feel free to drop a comment if you have any questions.